The 1-minute concept is a great way to teach another person the main ideas of the concept. Let's look at a 1-minute concept. What I want you to notice here is that it's 1/2 to one sheet of paper. It's very visual. There's few words or equations. Let's look at the parts of a 1-minute concept. There's a title, in this case, minor loss coefficient. There's a description of meaning. There's a statement of why you would want to learn this. And then there's a visual with some text or equations that provide some ideas of the meaning. Let me give you an example of how I would use this 1-minute concept to teach. Okay, a concept that you want to know is called the minor loss coefficient, and this is used in conduit flow. The definition of the minor loss coefficient, it's given the symbol K, and it's defined as the head loss for flow through a component or transition divided by the velocity head in the system. Why would you want to know this? Well, if you can calculate the head loss associated with the components and transitions and pipes, you can get things like pressure drop, the power required by a pump, and this is key information for designing a piping system. In this system, water flows from an upper reservoir to a lower reservoir. Each component or transition has an associated minor loss coefficient or K values. K values are found from tables and charts in engineering references. Here I'm showing typical values. K values that are given in references are valid only for turbulent flow, which occurs when the number is greater than 3,000. If you have laminar flow, you have to find K values from the literature. Each minor loss represents a conversion of mechanical energy to waste thermal energy through the actions of viscosity. For example, near an entrance, flow often separates, and there's an eddying flow, and this flow separation causes a loss of mechanical energy, which is represented with the minor loss coefficient for an entrance. Notice also that each K value is given a subscript. A lowercase e means this is the minor loss coefficient for an entrance. A lowercase v means a minor loss coefficient for a valve, etc. When we want to do calculations, it's very simple. We add up the minor loss coefficients for each component in transition and multiply it by the velocity head. Then we add the head loss associated with flow in pipes by using the Darcy-Weibach equation. In summary, the 1-minute concept is a tool for explaining concepts to other people.